Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed chapter number 16, probability. Hope it was clear for you all. In today's session, we will begin a new topic, that is limits and derivatives. Let's move on to the topic. Let's begin with the term limits. Consider an expression x square minus 1 divided by x minus 1. Here, let's try to find out the value of the function x square minus 1 divided by x minus 1 when x is equal to 1. Means we have to replace this x and we have to substitute its value, that is 1, given to us. So 1 square minus 1 divided by 1 minus 1. What we have done is, instead of x we have substituted 1. So 1 square is 1. 1 minus 1 divided by 1 minus 1, that is equal to 0 by 0. So division by 0 is not possible, and 0 by 0 it is said to be indeterminate. Means it is not possible to find out the value of 0 by 0. Now for x is equal to 1, the value of this function is indeterminate. Now let's try to find out the value of this function some other way by putting some different values. That is, starting from x is equal to 0.5. When x is equal to 0.5, we have to replace x and put 0.5, that is 0.5 square minus 1 divided by 0.5 minus 1. So what we get here is 1.5000 will be coming. You can use your calculator to find out if you want. Then 0.9, when we substitute, we will get 1.9. 0.99, that is very close to 1. We will get as 1.99, and again 0.999, we will get the value as 1.999, and 0.9999 when we substitute, we will get 1.999, and when we substitute very close to 1, the value 0.99999, we will get 1.9999. So here, now we see that as x gets closer to 1, as we know that we have started from 0.5 and we are just coming closer to 1, means 0.99999. When x is starting from 0.5 and coming to very close to 1, means x is approaching to 1, we are getting the value of the function approaching to 2. That is 1.999 is very close to 2. So the value of x starting from 0.5 when we substitute till 0.999, which is very close to 1, means the value of x is increasing from 0.5 to 1. We will get the value of the function x square minus 1 by x minus 1 is approaching to 2. So let's try it from the other side. Other side in the sense, you can see there is a number line, and in this number line the value of 1 or the 1.1 is marked in the middle, and left side is 0.5 and right side is 1.5. And first we have substituted from 0.5, means left side of 1 we have substituted, and we have got the value of the function is approaching to 2. And now we'll try from the another side, means from the right side. Let's check. That is, here x and x square minus 1 divided by x minus 1, the two columns as before. We will start from 1.5. 1.5 when we substitute, we will get 2.5. 1.1 we substitute, we will get 2.1. 1.01 when we substitute, 2.01. 1.001 when we substitute, it is 2.001. 1.0001, this is also very close to 1. We will get a value which is very close to 2. And 1.00001 when we substitute, we will get 2.00001. So this is the value of the x when x is approaching to 1 from 1.5. From the right side of 1, when x is approaching towards 1, we will get the value of the function also approaching towards 2. Means more or less from both the cases the value of the function is approaching towards 2. Here it is 1.999, very close to 2. Here we have got 2.0001, it is very close to 2, but they are not equal to 2. 1.99999 and 2.00001, these two are not equal to 2, but they are very close to 2. So here also the value of the function is heading towards 2. Then we can say that x square minus 1 divided by x minus 1 gets closer to 2. In these two conditions also, the value of the function is gets or tending towards 2. And when you see limit, here is the concept of limit comes. When you see limit, think it is approaching. Here you can see the value is approaching towards 2, and here also the value is approaching towards 2 from both the sides. 1 is the middle value, and from the left, if you have considering also, it is approaching to 2, and from the right of 1, if you put also, the value is approaching to 2. And it is written in symbol as limit x tends to 1, x square minus 1 divided by x minus 1 is equal to 2. Here we read as limit x tends to 1. Here LIM is mentioned. In some cases or some textbooks, it is written as LIT or LT. So limit LT also we can write, LIM also we can write, it's not a problem. Limit x tends to 1. X, there is an arrow 1. We read as x tends to 1. X square minus 1 divided by x minus 1 is equal to 2. We read as x tends to, moving towards or approaching. When we show it graphically, it comes like this. From here also it is approaching to 2. From the right side also, or it is approaching to 2. But there is a hole, means exactly not 2, but it is tending towards 2. Then in truth, we cannot say that the value at x is equal to 1 is, but we can say that as we approach 1, the limit is 2. Here we cannot, in truth, we cannot say what the value at x is equal to 1 is. We are not able to tell at x is equal to 1 what the value is, because it is indeterminate, 0 by 0. But we can say that something like this, when we approach, as we approach to 1, the limit is 2. Next, let's try to define the limit of a function. Let f be a function and x tends to a and f of x tends to L, then L is called the limit of the function f of x, written as limit x tends to a, f of x is equal to L. Here let f be a function and x tends to a and f of x tends to L, as we have done in the previous slide. X is tending towards 1, then the function, the value of the function is tending towards 2. So here x tends to a, f of x tends to L, then L is called the limit of the function f of x, written as limit x tends to a, f of x is equal to L. Here limit x tends to a minus in the sense the left side of a minus f of x is expected value of f at x is equal to a, given the values of f near to the left of a. This value is called the left hand limit of f at a. Here limit x tends to a minus of f of x is the expected value of f, the value of the function at x is equal to a, given the values of f near to the left of a. As we have done in the previous slide, 1 we have considered as the value and we have taken the values from the left of a, that is called a minus. This value is called the left hand limit of f at a, and limit x tends to a plus f of x is the expected value of f at x is equal to a, given the values of f near to the right of a. In the previous slide, we have substituted the values from 1.5 to 1. That is the right side values of 1. This value is called the right hand limit of f at a. So when we say about limit, there are two kinds. One is left hand limit of a, mentioned as a minus, and another one is the right hand limit of f at a, that is a plus. If the right hand and left hand limits coincide, we call the common value as the limit of f at x is equal to a and denote it by limit x tends to a, f of x. And in the previous example, we have concluded that both the values are coinciding at 2, just approaching towards 2. So we have written as limit of the function is 2. Here, if the right and left hand limits coincide, we call the common value as the limit of f at x is equal to a, and it is denoted by limit x tends to a. Here there is no plus and minus, x tends to a only will write limit x tends to a, f of x. Next, there is a question arises when it is different from different sides, from the left hand side and from the right hand side. If we are approaching towards different values, what we can conclude? That is what the question. So graphically here shows some values, and here in this left side, if you check, the value is tending towards 3.8, and right side limit, if you check, the value is tending towards 1.3. Means these two values are not coinciding. Like in the first slide we have discussed about the case of 2. Here in the left hand side it is approaching towards 3.8, and in the right hand side the value is approaching towards 1.3. Means limit extends to a minus, means the left hand side limit is approaching towards 3.8 or equal to 3.8, and the limit extends to a plus, that is the right hand side, f of x is equal to 1.3 we are getting. So both the sides are not coinciding. That means limit x tends to a, f of x does not exist. Means the left hand side limit and the right hand side limits are not coinciding. Then we can come to the conclusion that limit x tends to a, f of x does not exist. A function f of x with a break in it, the limit does not exist at a. Means in this case the right and left hand limits are different, and hence we say that the limit of f of x as x tends to a does not exist. Next, we shall discuss some important results. Algebra of limits. Let f and g be two functions such that both limit extends to a f of x and limit extends to a g of x exist. Then limit extends to a f of x plus g of x is equal to limit extends to a f of x plus limit extends to a g of x. Means we have to take limits separately and add. Then same way, if it is minus comes, limit extends to a f of x minus g of x is equal to limit extends to a f of x minus limit extends to a g of x. Limit extends to a f of x into g of x is equal to limit extends to a f of x into limit extends to a g of x. Here also take the limit separately and multiply. Then limit extends to a f of x by g of x is equal to limit extends to a f of x divided by limit extends to a g of x. In division also take the limit separately and divide. Limit extends to a lambda into f of x is equal to lambda into limit extends to a f of x. Here lambda is a constant. If a constant is there along with the function, then we have to take the constant separately outside, then apply the limit extends to a f of x. Limits of a polynomials and rational functions. If f is a polynomial function, then limit extends to a f of x exists and is given by limit x tends to a f of x is equal to f of a. Means here simply you have to replace x and substitute a, you will get the limit. So limit x tends to a f of x is equal to f of a. Just substitute a in place of x, that's all. Next, an important result of a limit. For any positive integer n, limit extends to a x power n minus a power n is divided by x minus a is equal to n into a power n minus 1. Here both the base x and a should be there in the denominator, x minus a. So limit extends to a x power n minus a power n divided by x minus a is equal to n into the power into a, the value which is here, a power n minus 1. Just reduce 1 from the power, n into a power n minus 1. Limit extends to a x power n minus a power n divided by x minus a is equal to n into a power n minus 1. This is very important result. Next is limits of trigonometry functions. First case, limit x tends to 0, sin x by x is equal to 1. Second result, limit x tends to 0, cos x is equal to 1. And the third result, limit x tends to 0, sin x is equal to 0. These three important results we have to by heart. Limit x tends to 0, sin x by x is equal to 1. Here limit x tends to 0, only sin x, that means equal to 0. Limit x tends to 0, cos x is equal to 1. These three are the important trigonometric functions, limits of trigonometric functions. Next, we shall discuss the exercise questions. Exercise 13.1, question number 1. Evaluate the given limit x tends to 3, x plus 3. Limit x tends to 3, x plus 3 is equal to, just you have to replace this x and put the value 3. That is 3 plus 3, that is equal to 6. Replace the value of x by 3. So 3 plus 3 is equal to 6. Question number 2, evaluate the given limit. Limit x tends to pi x minus 22 by 7. So here limit x tends to pi x minus 22 by 7 is equal to, replace x and substitute pi, that is pi minus 22 by 7. Question number 3, evaluate the given limit. Limit r tends to 1 pi r square. So limit r tends to 1 pi r square is equal to, r is replaced and put 1. So pi into 1 square, that is equal to pi. Question number 4, you will do it as homework. Question number 5, evaluate the given limit x tends to minus 1, x power 10 plus x power 5 plus 1 divided by x minus 1. So replace this x by minus 1. So limit x tends to minus 1, x power 10 plus x power 5 plus 1 divided by x minus 1 is equal to minus 1 the whole power 10 plus minus 1 the whole power 5 plus 1 divided by minus 1 minus 1. Just replacing x by using the value minus 1. So minus 1 the whole power 10. Power is an even number, so positive 1 will be coming. And here power is an odd number. That's why answer will be coming as minus. So minus 1 the whole power 5 is minus 1 plus 1 divided by minus 1 is minus 2. So here plus 1 minus 1 cancel. So 1 divided by 2 will be coming with a negative sign, minus 1 by 2. Next is question number 6. Evaluate the given limit. Limit x tends to 0, x plus 1 the whole power 5 minus 1 divided by x. Here we have to go for a different approach, because limit x tends to 0, x plus 1 the whole power 5 by minus 1 by x. If you do it in the previous method, means by replacing x by using the value 0, that is 0 plus 1 the whole power 5 minus 1 by 0. That is 1 power 5 minus 1 by 0, that is equal to 0 by 0. Indeterminate form we are getting. So we have to go with a different approach when these type of answers comes. So the value of the given rational function takes the form 0 by 0. Put y is equal to x plus 1. So this x plus 1 we have to substitute with another variable, that is y. Y equal to x plus 1. Here x is equal to, just we can calculate the value of x. Take this plus 1 to the left side, so y minus 1. Then as x tends to 0, that is what given to us, x tends to 0, what will happen to y? As x tends to 0, y tends to 0 plus 1. So here x value replaced and put to 0, so 0 plus 1, y tends to 0 plus 1. Here y tends to 1, means as x tends to 0, y tends to 1. That change, what change it is coming, that you have to find out here when you substitute with a different variable. So limit x tends to 0, x plus 1 the whole power 5 minus 1 by x is equal to, this x plus 1 you have replaced with y. So y power 5 minus 1 by y minus 1 is our new function. That time the limit is changing as y tends to 1. That change we have to calculate before. So limit y tends to 1, y power 5 minus 1 divided by y minus 1. So limit x tends to a, x power n minus a power n divided by x minus a. We have learned the formula n into a power n minus 1. So here you have to use the formula. Again, if you substitute 1 here, we will get a indeterminate form. So here there is a standard form we have reached. So by using the formula, standard formula, we have to write the result. X power n minus a power n divided by x minus a form. Here a power n in the sense 1 power n we can write. 1 power n is 1 itself. So that is equal to n into, n means the power. Power is 5. 5 into a power. A is here 1. So 1 power n minus 1. N is 5. So 5 minus 1. That is equal to 5 into 1 power 5 minus 1 is 4. 5 into 1 power 4 is 1 itself. That is equal to 5. 5 into 1 is 5. That is limit x tends to 0, x plus 1 the whole power 5 minus 1 divided by x is equal to 5. Move on to the 7th question. Evaluate the given limit x tends to 2, 3x square minus x minus 10 by x square minus 4. Here also, if you substitute 2 directly here, you will get 0 by 0 indeterminate form. So we have to go with a different approach. So limit extends to 2, 3x square minus x minus 10 by x square minus 4 is equal to limit extends to 2. Let's factorize this numerator. So here the product is minus 30, sum is minus 1. So product is minus 30 and the sum is minus 1 means splitting the middle term. We can use the numbers 5 and minus 6. 5 into minus 6 is minus 30. Then 5 minus 6 is minus 1. So it is suitable here. So 3x square plus this minus x we will split 5x minus 6x. 5 into minus 6 we will get the product that is 30 and 5 minus 6 is minus 1. So minus 1x will be getting here. So 3x square plus 5x minus 6x minus 10 divided by x square minus 4. Limit extends to 2. From here let's take x common. So if you take x common, 3x plus 5 minus, from these two we have 2 common, minus 2 common. Let's take out minus 2. Taking out means here 6 divided by 2, 6 divided by 2 is 3. So 3x, then 10 divided by 2 is 5. So 3x plus 5 divided by a square minus b square format. We have to change the denominator, that is x square minus 2 square. That is equal to limit extends to 2. Here 3x plus 5 is common. Let's take out. Balance in the first term there is x and in the second term there is minus 2. So x minus 2 into 3x plus 5 divided by a square minus b square is a plus b into a minus b. A plus b into a minus b is x minus 2 into x plus 2. So here x minus 2 in the numerator and denominator we can cancel because there is a common term. I am not showing the cancellation here, just to cancel it. Then limit extends to 2, we are getting the balance terms 3x plus 5 divided by x plus 2. Now we can substitute, there is no problem because indeterminate form will not come. That is, putting x is equal to 2, 3 into 2, x replaced by 2, 3 into 2 plus 5 divided by 2 plus 2. That is equal to 3 into 2 is 6, 6 plus 5 divided by 4, that is equal to 11 divided by 4. So the value of the given limit is, or limit extends to 2, 3x square minus x minus 10 divided by x square minus 4 is 11 divided by 4. Move on to the 8th question. Evaluate the given limit. Limit extends to 3, x power 4 minus 81 divided by 2x square minus 5x minus 3. In this case also, when we substitute x directly here, we will get indeterminate form, 0 by 0 form. So we have to go with a different approach. Different approach means it's quite simple one, just to factorize and cancel the common terms. At x is equal to 2, the value of the given rational function takes the form 0 by 0. Limit extends to 3, x power 4 minus 81 divided by 2x square minus 5x minus 3 is equal to, this is a square minus b square format. A square minus b square, here x power 4 is there. X power 4 means 2 times we have to do the factorization. So x power 4 we can split as x square the whole square minus 9 square, 81 is 9 square, divided by, here splitting the middle term. If you don't know the splitting the middle term factorization method, just revise class 10 textbook or else you can ask in the discussion session. So 2x square minus 5x minus 3, here product is minus 6, sum is minus 5. Product minus 6, sum minus 5. There are two numbers, that is minus 6 and 1. Minus 6 plus 1 is minus 5. Minus 6 into 1 is minus 6. So we have to split this minus 5x by using these two numbers, minus 6x plus x. The remaining terms are same, 2x square and minus 3 are same, first and last term. Then let's go for factorization. A square minus b square. A square minus b square is a minus b into a plus b. Here a is x square, b is 9. So a minus b, x square minus 9 into a plus b, that is x square plus 9 divided by, in these two there is a 2x common, take out. 2x taking out means the first term x balance. 2x square was there, 2x we have taken out, then only x balance. Minus, from 6x if you take 2x outside, there is only 3 balance, so x minus 3. Plus in these two there is nothing is common visibly, so 1 we can take out, 1 into x minus 3. By using a square minus b square formula we have done the calculation. That is limit extends to 3. This x square minus 9, again it is two perfect squares difference. We can use again a square minus b square formula. So we have to split x square minus 9 we have to write as 3 square. Here there is nothing can be done, x square plus 9 as it is. And here x minus 3 is common in denominator, take out x minus 3. In the first term x minus 3 going means there is 2x and there is 1 in the second term. So 2x plus 1 into x minus 3. Then limit x tends to 3, x minus 3 into x plus 3. This one again we are using x square minus b square formula, a minus b into a plus b. Here a is x, b is 3. So a minus b, x minus 3 into a plus b, that is x plus 3, into x square plus 9 as it is. Denominator is 2x plus 1 into x minus 3. Then here x minus 3 is common in both numerator and denominator, just cancel it. Then limit x tends to 3, we are getting the balance items x plus 3 into x square plus 9 divided by 2x plus 1. Now it is safe to substitute. No 0 will be coming because there is subtraction terms are cancelled. Then when we substitute x by 3, then 3 plus 3 into 3 square plus 9 divided by 2 into 3 plus 1. That is equal to, here 3 plus 3 is 6. 6 into, here 3 square is 9, 9 plus 9 is 18. So 6 into 18 divided by 3 into 2, 6, 6 plus 1 is 7. That is equal to 108 divided by 7. That is the answer. Move on to the 9th question. Evaluate the given limit. Limit x tends to 0, ax plus b by cx plus 1. This question you will try it as homework. Question number 10. Evaluate the given limit. Limit z tends to 1, z power 1 by 3 minus 1 by z power 1 by 6 minus 1. Here, when we substitute directly by replacing z as 1, we'll be getting 1 minus 1 by 1 minus 1, 0 by 0 indeterminate form. So at z is equal to 1, the value of the given function takes the form 0 by 0. Put z power 1 by 6 is equal to x. That is what we have to do here. We have to change this z power 1 by 6 with a x. So that as we are changing this variable z power 1 by 6 as x, changing the variable to x, we have to change the limit also. Limit z tends to 1. As z tends to 1, here 1 power 1 by 6. 1 power 1 by 6 means 1 itself. So x is equal to 1 we are getting. So x is tending towards 1. So both are tending towards 1 itself. Z tends to 1 as x tends to 1. Limit z tends to 1, z power 1 by 3 minus 1 divided by z power 1 by 6 minus 1 is equal to, here little bit of care we need, z power 1 by 3. Actually we have substituted for z power 1 by 6. Z power 1 by 6 the whole square, when we take, we can multiply this 1 into 2. So we will be getting as z power 2 by 6. Here 2 and 6 when we cancel, we will get 1 by 3. Z power 1 by 3 means z power 1 by 3 is same as z power 1 by 6 the whole square. We have substituted z power 1 by 6 as x. Means x square is same as z power 1 by 3. That is what here x square came in place of z power 1 by 3. So x square minus 1 divided by z power 1 by 6 is x itself. So divided by x minus 1. Now this is of the form x power n in minus a power n divided by x minus a. So the formula is n into a power n minus 1. N is 2. 2 into a is 1. 1 power 2 minus 1. N minus 1 is 2 minus 1. So 2 into 1 minus 2 minus 1 is 1 power 2 minus 1 is 1 itself. 2 into 1 is 2. So the answer is 2. Next is question number 11. Evaluate the given limit. Limit x tends to 1. Ax square plus bx plus c by cx square plus bx plus a, comma a plus b plus c not equal to 0. This is a direct question. This you will try it as homework. Move on to question number 12. The question is evaluate the given limit. Limit x tends to minus 2. 1 by x plus 1 by 2 by x plus 2. Here also when we put directly minus 2, it will be coming as 0 by 0 format. So at x is equal to minus 2, the value of the given function takes the form 0 by 0. So we have to go with a different approach. Here it is quite simple. Let's take the LCM of the numerators. So limit x tends to minus 2, 1 by x plus 1 by 2 by x plus 2 is equal to limit x tends to minus 2. Common denominator here, denominators are here x and 2. Let's take the common LCM. that is 2x is the LCM. 2 into 1 is 2 plus 1 into x is x. So 2 plus x by 2x by x plus 2. Now you can see here numerators. Here 2 plus x, denominator there is x plus 2. Both can be cancelled. So we'll be having only 1 by 2x. Limit x tends to minus 2, 1 by 2x. Let's substitute it. That is 1 divided by 2 into minus 2. 1 divided by 2 into minus 2 is equal to minus 1 by 4. Next, question number 13. Evaluate the given limit. Limit x tends to 0, sin ax by bx. So the limit of trigonometric functions we have to use here. We have learned a formula. Limit x tends to 0, sin x by x is equal to 1. So here sin ax by bx means here ax is there. In the denominator, if there is ax, then we can apply the formula. So limit x tends to 0, sin ax by bx is equal to limit x tends to 0. We don't want this bx. So we have to separate it first. So limit x tends to 0, sin ax into 1 by bx. Then multiplying and dividing by ax, because in the denominator here we want an ax. Then only we can apply the formula, because the same angle we need in the denominator. So limit x tends to 0, sin ax into 1 by bx, the same quantities. We are multiplying and dividing by ax, that is ax by ax. Then we can group it. This sin ax by ax we can group. So limit x tends to 0, sin ax by ax into, there is one ax in the numerator balance, denominator there is a bx. So ax by bx. Here you can see x and x common. If you cancel x and x, a and b will be a divided by is a constant, we can take out. That is limit x tends to 0, sin ax by x into a by b, x and x cancelled. Then we will bring this one to another side. Another side, no, beginning. That is a by b into limit ax tends to 0, sin ax by ax. Because here ax is there as an angle. So here we have to change this limit x tends to 0. So we know that x tends to 0 means ax also will be tending to 0, because it is a product. So x tends to 0 implies ax tends to 0. So you have to write the limit in the same way. Limit ax tends to 0, because here there is ax. Limit ax tends to 0, sin ax by ax. This a by b we have taken in the beginning. That is equal to a by b into, there is a formula, as we know that limit ax tends to 0, sin ax by ax. By using the formula we can write it as 1. The formula which we use is limit x tends to 0, sin x by x is equal to 1. So now a by b into 1 is equal to a by b. That is the answer. Question number 14. Evaluate the given limit. Limit x tends to 0, sin ax by sin bx. A comma b not equal to 0. Here, if you substitute directly 0 here, it will be coming 0 by 0 format, indeterminate form. At x is equal to 0, the value of the given function takes the form 0 by 0. But we can use the formula here. You can see sin ax. The denominator is having an ax. We can use numerator formula. And denominator sin bx is there. If you are dividing with the bx here, again denominator also we can use the trigonometric formula. Limits of trigonometries. Then we can try to do that way. We will try to do that way. That is limit x tends to 0. Sin ax by sin bx is equal to limit x tends to 0. We want the denominator ax here. Just to put it, multiply one more ax so that it will be balanced. Denominator we want a bx. Just to put it into bx, we do it. Then it will be balanced, because bx and bx cancelling time, sin bx only will be coming. And here x and x we can cancel, only a by b is a constants both. So take this a by b in the beginning. So a by b into limit, here x tends to 0, but here ax. As x tends to 0, ax also tends to 0. So limit x ax tends to 0, sin ax by ax. That take the limit separately in the numerator and the denominator. Limit here bx is there. As x tends to 0, bx also tends to 0. Limit bx tends to 0, sin bx by bx. The reasons we have explained. So a by b into limit ax tends to 0, sin ax by x. Both numerator and denominator, by using the formula will be getting us 1 divided by 1. That is equal to a divided by b. Then here question number 15 we have to discuss. Evaluate the given limit. Limit x tends to pi. Sine of pi minus x divided by pi of pi minus x. Let's try this one. Let y is equal to pi minus x. Just replace this pi minus x by y. Then when x tends to pi, here it is given x tends to pi, y tends to, this x replaced with the pi, y tends to pi minus pi. Pi minus pi is 0. Y tends to 0. As x tends to pi, y tends to 0. So here we are changing to y. So this limit also we have to change. So limit x tends to pi, sine pi minus x by pi of pi minus x is equal to, we are changing the limit y tends to 0. This will be coming as sine y divided by pi into y. So sine y divided by pi y, because pi minus x we have substituted as y. Denominator there is a pi already is there, so pi into y will be coming. Then take this pi outside, because pi is a constant. We don't want here, just to take it out. That is equal to 1 by pi into limit y tends to 0 sine y by y, purely in the trigonometric limit formula form. So limit y tends to 0 sine y by y, that is 1 by pi into 1. Directly we can apply the formula here. So 1 by pi into 1 is equal to 1 by pi. That is the answer. Dear students, in today's session we have discussed the basic concepts of limits and we have solved first 15 questions from exercise 13.1. I request all the students to go through the video very carefully and solve all these questions independently. And while solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.